So this is the second video in the series that's going to show you how to use Fusion 360 to create your G-code programs or your posts. So in the first video, we created the new setup for this sign that we're going to make. This second video, the first thing that we really need to get into is managing the tool library. So what you're going to be doing is you're going to be using these 3D operations, 2 and 3D operations to create your designs. But before, the first thing you have to do in operation is select a tool. So what we have to do is load a tool library with the tools that we need to use. If this is your first time in Fusion, you will probably see just a bunch of generic cutters available here. I've kind of turned my library off because I use the one I've loaded. And that's what I recommend you do. So if you go to the local tab and go to library, you probably won't see anything here. So you'll be creating your library from scratch, essentially. So what you're going to do is click this plus button to add your first tool in. Now, depending on what tool you're doing, what operation you're doing, some of the more common ones that you're probably going to be doing right off the bat is flat end mills for doing any contours, cutouts. You may be doing some face milling if you're trying to essentially plane a board, probably some engraving bits, 60s, 90s. Those are kind of the most common things that you're going to be doing to start off. If you're doing 3D cards, you'll be getting into ball end mills and tapered ball end mills, because that's how you can get the best bang for your buck for your 3D cutouts. But for our purposes here, we're going to be using the flat end mill. And when I build this tool, I need to put all the information in here so the computer can reference. Now, the first tab is general. What it asks for is a description, vendor, product ID, link. For the sake of continuity, if you bought your tool from Freud or Amana or whoever your preferred vendor is, I recommend that you put that information in here. Put the description of the tool, the vendor, the product ID, so that when this tool wears out, assuming you liked it, you'll know exactly which one to buy. You won't have to crack open the catalog and try and work backwards to figure out what you bought. It just makes everything a little bit easier. Once you get into cutter, this is where we need all the information about the size of the bit, how many flutes it has, what's the material. Shaft and holder I don't really use too much, but it's there if you need it. Cutting data is probably the most important piece here. When we open an operation, this default cutting data for the bit that we select is what populates. So the closer you get this with your most common parameters for your cutter, the faster you're going to be able to set up CNC programs in the future. As far as your post processor here, what's really important is that if you have a tool changer on your machine, that this number matches the location of the tool on your machine. When your CNC machine is changing tools and goes to grab something, you want to make sure it's grabbing the right thing, or you're going to be wasting material and starting over. So that's really where this tab comes into play. All right, for our work here, let's just say we're going to use this Freud bit here. I just loaded a couple generic bits. If you bought a bit, you're going to see on the back of the package this information is here. It's going to tell you a little bit of information about your cutter. So it's a 2.5 inch overall length. It's a 1/4 inch shanked bit. Overall cutting diameter is 1/4 because it's a straight bit. Tapered bits or something else, that's going to be a different number. Your carbide height essentially is your cutting height. So you can cut in one pass material up to 3/4. Not recommending you do that, but you could with that cutting height. It gives you a max RPM, and very importantly, when it comes to calculating speeds and feeds, is number of cutters. So I'm going to go ahead and populate this information into here. Now, like I said before, if I was a big buyer of Freud bits and I really like this cutter, what I should do is take this information and put it straight in to my description. This is what I would do if I was using these all the time. This is a future time saver. And especially if you end up doing a lot of machining, the more information with each bit, the better. All right, so our cutter is a flat end mill. We're working in inches, clockwise rotation. This has 2 cutters, not 4. And this is a carbide material. Let's see, that the shank is a 1/4 inch. Overall length was 2.5 inches. Now it didn't give me this information, length below holder, because this depends on where you chuck it into your machine or your collet, and shoulder length. But I do know the flute length is 3/4 inch. So as long as these work, the computer's not going to throw any red flags at you. I'm not going to dive into shaft and holder at this time, but if you needed to, you could. Cutting data is probably the most important thing here. Let's say I did a calculation earlier, or just from experience, I know that this cutter and my machine work really well together at 18,000 RPM, which on my Shark, they actually do. I'm going to have the same ramp spindle speed. I'm going to let the cutting feed rate be dictated by my feed per tooth, which I like at 3,000ths of an inch, or 3,000ths feed per tooth. That's always where I start, unless I'm working with something specifically hard or really, really soft like plastic that I know I need to go really quick. So that's kind of my default. And this is going to be good enough for me to see how the machine's working. It's always good to be a little more conservative the first time you run a program, and then you can kind of dial it in after that. Let's see here. Vertical plunge. Yeah, I'm going to leave those. With the flat end mill, we want to go vertically. We want to be careful and go slow with that. So I'm going to leave those. And post-processor, let's just say this is going to be tool number 2, because in my machines, that's what they are. All right, at this point, I don't think we have to worry about live tool or manual tool change. I mean, I could click that if I know I have it, but I'm going to be doing it manually anyways. All right, so at this point, that's the tool I just made, which almost mirrors some of the other stuff I've done. But that's going to be your tool. So once you have that, I recommend you load everything you need in, at least for the project that you're cutting at the time. But at some point, you'll probably just have this bank of all the different tools that you have. So as you can see here, if you get a lot of different bits, it's really important to know which one you have available, so you select the right one. If you're a student in my class, you're going to load in the ones based on the information I give you on this chart here. I find it easy to just put everything in one place, and if I go with a different vendor, I can change that information, but it makes communicating that really simple. All right, so once we have our tool library done, we are now ready to start working on creating operations to cut this out, to do some CNCing, and that will be in the following video. Thank you.